Here's a quick video on finding the volume of rotational solids using disks and washers. So this is in section 5.2. We're working on problem 42 right at the moment. The instruction says, find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the indicated line. So I'm revolving y equals x squared and y squared equals 8x around the line x equals 2. I took the liberty of writing those down. First off, I guess I got to get an idea of what that looks like. So let me graph this. I know that I'm somehow rotating everything around this line. X equals 2. So that's the all-important line. This graph, I have a pretty good idea of what it looks like. Right? What's this graph look like? I guess when x is 0, y is 0, so it goes through there. When x is 1, this is the square root of 8, which is a little bigger than 2, right? And this is somehow a parabola on its side. Now, y could be that positive value, or it could be that negative value. So we've got some region like this, right? Well, gee. So I wonder where those two curves cross up here, because that, I guess, is the region I really care about. Don't care so much about those things. How do I figure out where those two crossed? You guessed it. Set them equal to each other. So if I plug that in, I substitute that in for y, I get actually, let's see, x squared squared, so that's x to the 4th equals 8x. Can you see that one of the solutions to that would be x equals 0? Dividing both sides by x, though, to get the other solution, I would get x cubed equals 8. Well, where does that land us? The cube root of 8 is 2. So I guess those cross at 2, and you can double check that too. Okay, so I'm rotating that around this axis. Now if I'm going to use the disk method, the cuts are going to be perpendicular to that rotational axis. So I'm looking at cuts like that. I have to ask a couple of questions. I have to ask, well, given that my slices are going to look like that, what's the outside radius? What is that outside radius? I guess I'm cutting along the y-axis, right? I'm cutting from here up to there along that axis. So this is going to be a dy integral. And I start cutting at 0. I wonder where I finish cutting there. I know I go 0 to 2 in the x direction, but I go 0, I guess, to 4. When that's 2, that's 4 in the y direction. I said y, didn't write y. So I'm cutting along the y-axis from 0 to 4. So I have to describe my radius in terms of y. What is this r, that capital R? Well, that outside radius, I guess, is the difference between the endpoints. This endpoint is at 2. This endpoint is at, well, if I'm trying to find the x value for that in terms of y, so this is 2 minus y squared over 8. Okay? This point minus that point. What about the inside radius? This inside radius r there, that's actually 2 minus the other function. Well, can you see that the other function is the square root of y? So what do I have? I have the area of the outside, that's pi capital R squared. So 2 minus y squared over 8 squared minus pi little r squared. I've got the pi factored out. 2 minus root y squared. Okay? So now we have a little bit of algebra to do, but our problem's mostly settled now. If if I multiply this out, I'm going to get 4 minus, let's see, if I multiply this times that, I'll get 1/4 y squared. I'm going to get 2 of those, so that ends up being 1/2 y squared plus 1/64 y to the 4th. This one I get minus 4. Have to remember to distribute that negative sign. Then multiplying these, I get negative 2 root y, but I get 2 of them, so negative 4 root y. Distribute this negative sign and I get a positive. And the last term will be negative, and this will just be y. Okay, so that was pretty exciting there. Now time to integrate all that. Let's see what we've got. This integrates to 4y. This integrates to 1/6 y cubed plus, let's see, 1 over, I'll write 64. I guess that's 2 to the 6th times 1/5 y to the 5th minus, I can cancel 4 and minus 4. That's convenient. So I'll just erase that entirely. Plus, let's see, this is y to the 1/2. So now I'm going to have y to the 3/2, right? So I need to multiply by 2/3 in front and by 4, so that's 8/3. And then here I'm going to have minus 1/2 y squared. That's all evaluated from 0 to 4. So let's see what we get. Okay, so I get, evaluating at 0 is real nice, it'll give me 0. So I just have to evaluate really at 4. 4 to the 3rd is 64, divided by 6 is negative 32/3. Okay, here I have, now 4 to the 3rd is 64, so 3 of those 4s is going to cancel with that. I have 2 4s left over, so that's plus 16/5 plus, let's see, the square root of 4 is 2, then to the 3rd power is 8, so that's 64/3 minus, this is 16 over 2 minus 8. I'll let you work that out, but that is the volume of this rotational solid.